When metallic atom loses electrons and non-metallic atom gains electron, they form the ionic compound. That same ionic compound can be decomposed into the positive and negative ions by which they are made up of, either by thermal decomposition or by electricity. Electrolysis is all about the decomposition of an ionic compound by electricity. Let's discuss how this works. This is a typical electrolytic cell. There are the two rods dipped into the solution, connected with the power supply, and in between rods and the power supply there is also lamp or any kind of the load that could be attached. The positive rod is called as an anode, the negative one is called as cathode. The solution that is in which the rods are dipped, it is called as an electrolyte. So this is the typical construction of the electrolytic cell made up of positive and negative electrodes, cathode and anode, and the electrolytic solution. The electrodes are of two types. One electrode is called as an inert electrodes and the other one are called as non-inert electrodes. Now inert electrodes are those electrodes that are either made up of carbon, platinum or graphite. They are called as an inert electrodes because they are unreactive. And the non-inert electrodes, they can be made up of any metal other than these three substances. Let's take an example of copper. Copper can act as a non-inert electrode, lead or any other metal that could be used as a non-inert electrode. Non-inert electrodes are the reactive electrodes. They react themselves in the solutions, but the inert electrodes do not react. Now, if we talk about the electrolyte, electrolyte is also of the two types. Either it is in the molten form or it is in the aqueous substance that undergoes the electrolysis. So there will be the two types of the electrolytes that we will be discussing throughout this lecture. Aqueous substances. So this is all about the typical electrolytic cell. Its construction involves the electrodes, power supply and the electrolyte. Electrodes can be inert and the non-inert electrodes. Inert electrodes are made up of carbon, platinum, graphite. Non-inert are platinum, copper. Sorry, it's not platinum, it's the lead, Pb. It could be silver, it could be gold, any other metal can be used over there. They are the reactive electrodes, they react in the solution. If we talk about electrolyte, electrolyte is the molten or it is in the aqueous substance. Molten means without water. So molten substances are those substances in which there is no water present, but the aqueous substances are with water. So it is without water. Let's now discuss about the transfer of the charge during the electrolysis. In order to discuss the transfer of electric charge, let's discuss the electrolysis of the molten lead bromide using inert electrodes. Now in molten lead bromide, if we will break this compound into the ions, so we can clearly see there is the no water, molten is present, molten is mentioned over there, so it means there is lead ion. Lead is symbolized by Pb. It is a transition element having 2 in the brackets, so it means Pb plus 2 and there is the bromide ion Br minus 1. So this is the positive and negative ions present in this molten lead bromide. What happens when the compound is in the molten form? There is one positive and the negative ion. They will be attracted towards their oppositely charged electrodes. For example, the positive electrode will be attracted towards the cathode, which is negatively charged electrode. Negative atom will be attracted, negative ion will be attracted towards the positive electrode, it's an anode. So when they will be attracted towards their oppositely charged electrodes, after reaching over these respective electrodes, they will react there. For example, for the positive ions, they gains electron from the cathode, because cathode, as we know, it's a negatively charged electrodes. So they will gain electrons from the cathode and will be neutralized over there. If we talk about Pb plus 2, so it has lost 2 electrons. So what they are going to do, they will gain 2 electrons. Whatever is lost from the lead, so it will gain 2 electrons and form lead metal. So there will be the deposit of the lead. So this is Pb, metal deposited. We can mention that metal deposited. If we talk about anode, in the same way, there is the bromide ion. Anode, bromide ion will be reacting at anode by the loss of electrons. So in this way, it's a bromide atom, bromide ion. So Br minus 1, it will lose 1 electron like minus 1e and will form lead atom. So this is how the molten lead bromide works. In this molten lead bromide, there are the there is one positive and the negative ions. They will be attracted towards their oppositely charged electrodes and they will react over there. Remember this thing, that the positive ions, the metallic ions, they always try to gain electrons from the negative electrodes in order to neutralize themselves. The negative ions or the non-metallic ions, they always tries to lose electrons at the anode except hydrogen. So let's discuss this transfer of electron. If we apply the same process in the electrolytic cell, so what happens, there is the positive electrode and the negative electrode in the solution. Now there are the two ions, there is lead bromide ion Pb2 plus and bromide ion Br minus. After some time, they will be attracted towards their negative oppositely charged electrodes, like bromide ion will be attracted towards the anode and the lead will be attracted towards the cathode. So the ions will travel through the electrolyte. Now if we talk about the combination of the charges, that how there is the charge of the transfer of the charge. So what happens, there is the traveling of the ions, they travels through the electrolyte. So first of all, this is the first point which you should know, that there is a movement of ions in the electrolyte, movement of positive and the negative ions in electrolyte. There isn't any kind of movement of electrons in the electrolyte. The ions are moving, like positive ion moves towards the negative electrode and the negative ion moves towards the positive electrodes. So by which medium they are traveling? They are not traveling by the air, they are traveling through the electrolyte in the solution. So there is a movement of ions by the electrolyte. Secondly, if we talk about the loss or the gain of electrons, so in this example we explained that there is the gain of electrons. Lead metal, positive metal gain electron from the cathode. So in the cathode there is a gain of electron. At the anode there is the loss of electrons. So let's mention also this one, that there is the gain of electrons at cathode, because cathode is negatively charged. So ions, positive ions will easily gain electrons from the cathode, and there is the loss of electrons at anode, which is a positive electrode and cathode is a negative electrode. So what happens when the electrons are lost at the positive electrodes, like in this way? So this electrode is connected with the power supply, the path is completed. In between that path, if we would like to run any load, it will easily be working over there. So electrons will be traveling from rods, from electrodes towards these external circuit. This is the part of the external circuit. Electrons will travel through the external circuit, the ions won't travel over there. So this is the third point of this movement of the charges, that the electrons travel through the external circuit. Electrons travel through the external circuit. External circuit. So this is all about for the electrolysis basics and the molten electrolysis. Electrolysis is simply the decomposition of an ionic compound by electricity. and electrolysis basically occurs in the electrolytic cell. So electrolytic cell is made up of the positive and the negative electrodes, which are either inert or the non-inert. They are said to be inert if it is made up of carbon, platinum or graphite, and non-inert if it is made up of copper, lead or any other metal other than these three substances. Now electrolyte is the solution from which the ions travels towards their respective electrodes and they are neutralize themselves at the electrodes. So electrolyte is a medium, it's a solution. It could be molten, it could be aqueous substance as well. In this lecture we have discussed molten electrolysis so far. Transfer of the charges is simple, that there are the ions that are traveling through the electrolyte. There is the gain of electron at cathode and the loss of electron at anode, and electrons travel through the external circuit. So this is all about for this lecture, and see you in the next lecture. We will be discussing about the aqueous solution electrolysis. Bye bye.